All right, in this video lesson, I want to talk about the difference between correlation and association. We'll also talk briefly about the correlation coefficient. All right, so we talked a little bit about correlation and that correlation only applies in situations in which you have numeric data or quantitative variables. All right, so in those situations, correlation applies. Correlation also only applies when we're talking about linear relationships between data. Okay, so in all other instances, what we're describing is associations. Okay, so let's look at this first one. This first graph here, you can kind of imagine that from your days of Algebra 1, you could draw a line of best fit through here, and that line would fit the data pretty good. The data is not too far away from the line of best fit. In this one, so what we could say here is that this data has a strong positive, change pens here, strong positive association. Okay. In other words, the data is fairly close together, and since it's linear, and we're going to assume both variables are numeric because we're putting it on the xy axis here, so they must be. It also has a strong positive correlation. All right. In fact, the correlation coefficient, which tells us how strongly correlated they are, the data is 0.82. So that is represented by R, and it's equal to 0.82. All right. Correlation coefficient runs from -1 to +1. All right, and the negative does not imply less correlation. It just implies a negative slope of the line of best fit. Okay, so -1 would be perfectly correlated data that basically that lies directly on a line. +1 would also be perfectly correlated data that lies on a line. Most data in the real world is not perfectly correlated. All right, so let's look at the next one. The next scatter plot here, we see a kind of a somewhat decent association. You could imagine a line of best fit down here that the data points wouldn't be too far away. And so we'd say this one has a moderately strong association. And because it's linear, it also has a moderately strong correlation. All right, this one has an R value of -0.57. Okay, again, the negative meaning that it's -0.57, clearly being further away from 1 than 0.82. So you can see that this data was fit a line better than this data did over here. 0.5 is a good cutoff for when what you might say data has a good correlation. So between 0.5 and 1, or -0.5 and -1. Let's look at this data down here, the third graph. This one has, you can imagine drawing a perfect parabola through this. In fact, I picked the data points such that they were on a perfect parabola. So if this was real data, it would certainly be related. And there's a very strong association. And so in fact, we should even just write that. There's a strong association, but there's not a correlation. All right. There are ways to make quadratic, exponential, logarithmic, that kind of data linear so that we can actually talk about correlation. We're not going to get into that. But for now, all you need to know is that, yeah, that is a strong association. There's no correlation, though. I'm not even going to write anything down. I don't think. I mean, correlation just doesn't make sense in the context of data that is related in this way. Okay. Let's look at this last one. This last one here, you might think, well, that doesn't look correlated at all. If you run the linear regression, and then what you find is that you have a very weak positive correlation. So, you can imagine drawing a line of best fit. Maybe it goes to something like that. But the correlation is really poor. Now, the reason it maybe doesn't look positive is because of the scale. We could make the scale kind of look positive, but running the program in your calculator to figure out the correlation will yield an R value of 0.2. Okay, so we'd say this has a weak positive association, and correlation. Okay, so then following these examples here, you can go flip to the next page and see if you can identify whether in those examples correlation is being used correctly or whether it's being used incorrectly. And that's about all we're going to go get into for correlation coefficient and association.